Hello, and welcome to this video, which is the part 2 of the secure hardware architecture module that we are covering in domain 3 at the moment. So what we have seen in the last session is we spoke at length about the main hardware components on which the computing runs, dominantly the CPUs, the central processing unit, and the peripherals around it. And today, in this session, we will go further and look into some of the inner details of how the hardware is set up. What are the principles that they are actually performing certain set of activities or computation, so to say. To begin with, what we have something called as the multi-threading, the multi-processing, tasking, and a programming capability. Though this word at times can be used interchangeably, they have a very distinct meaning in a pure technical sense. Multi-threading pertains to the ability of the CPU, which is having a single core at its disposal, is to execute a given task into different threads concurrently, which will help in speeding up the process. Multiprocessing is uh, nearly the same thing, but using more than one CPU. So it's not that one CPU having one core, but it's the ability to use more than one CPU to perform a given task. Multitasking is about running different tasks at the same time, and multiprogramming is the support of different programming concepts, different programs that basically runs on the system. For example, you can open the Word document and at the same time open the Chrome browser to perform two different things. All these activities or these concepts are implemented based on some hard design choices. For example, the memory protection, because you do not want a situation where a Word document that you are working on is get tampered by the Chrome session and that you have opened parallelly. So that's why the concept of memory protection becomes very important. Same is what you call as process isolation, the segmentation of the hardware, so that you have different memory aspect or the segments for different kind of things. Some of them which you do not want your user process to access, just like the kernel, what we have seen in the application design, the kernel being the innermost unit which is not accessible to the user. You also have different kinds of memories where it so happens that the information, for instance, remain persistent at some of the memories, while in the others it is more like you use it and then you discard it. Now, that's where, for instance, the concept of virtual memories comes into picture. And while swapping the information between two memory blocks, we use something called as paging, which is like switching off or passing off the information from one memory block to another, from temporary to permanent, or from in other configuration from a permanent to another permanent setup. Then this memory structure is also served by other implementation. For example, the media implementation. We have warm medias, which is write once and read many, which is the persistent set of information sharing for archival, because that is where the data remains untampered, because the data update or bit is been marked as inactive, so you cannot update the data. You can only write once and then subsequently you can only read. There is no manipulation possible. Uh, Going forward, we also look into some more core details. For instance, something called as a TPM, the Trusted Platform Module. And it's a module which has many different components which works together for your hardware to perform the task effectively but also securely. So you have what you call as the cryptographic processor, you have your random number generator for your cryptographic implementation, you also have your RSA key generator, you also have your key encrypting key processors in this, which helps to basically encrypt your private keys should you want to send it over a public channel and stuff like that. So TPM, and it's called trusted for a reason that if this is tampered, then you can assume and you can basically take it that everything else is broken. So that's why it is trusted. It remains that way uh, for the secure operation of your devices. Now we will look into some of these components when we get into the cryptographic module, that is what is a key encrypting key concept, why cryptographic and random number generators are so important a concept for the information security. But there are also other aspects that comes into play here. Important among them is what you call as an address space layout randomization. This is also an important concept because it protects your memory from getting attacked in terms of buffer overflow. Because if you have a static memory and the addresses are being static, then once the program, which are hard bounded, which means you have to define your variables in a hard bounded way, uh, if if they tend to get the values which is breaching their bounds, they also create problem in the segments of the hardware, because then they will start writing to the memory location to fix the bound problem. What the space layout randomization does is that prevent it from such an over exceed of the boundary by manipulating or changing randomly the address space, so that your hard bounded variables still remains within their own bounds. BIOS is another important component, and it is the first set where when you start your device, so to say, it is the first location that your operating system looks into for it to come to life, because what it checks not just merely the configuration of your operating system, but also some of the hardened security aspect, whether your TPM is not tampered with, whether your cryptographic key has not been tampered with, whether you are not running a jailbroken device and stuff like that, for it to bring your device to life, so that you can use it to do to perform various tasks. So BIOS is also very important, and there is another aspect to it, or another implementation, which is called hardware security module, which is also a component of TPM. And what it does is that it mainly plays the role of certifying the components which are in the TPM. So, for example, the certificate, it acts as a certificate authority for the components, your cryptographic key module, your key encrypting key modules, your random number generator, so that it has the operating system has the assurance that it is working with the valid components. Now, if you wanna ever know how the breaking of this architecture creates an issue, then I would highly recommend you to look at the meltdown attack uh, and and read about what what are the problems that in hardware configuration, when changed inadvertently, even by mistake, can lead to what sort of problem. So with this, I'll stop. Thank you very much for listening, and I hope to see you in the next session.